Welcome all to the next part of analog lecture series. I hope so far whatever the things that I have delivered you all understand. If you are really understanding the content whatever that I am delivering, don't forget to click that like button and also share it with all your friends. Okay, so let us take the next question. For this question we have to explore the value of voltage gain. Actually given it is, observe the question carefully. So here they have given one VCC actually. Yes, VCC is given and thermal voltage is given as 26 millivolt. We have to calculate the value of voltage gain. They told beta is very large and collector current also given by them. Collector current is 0.5 milliampere. Okay sir, when beta is very large, you know base current is approximately equal to 0 ampere. Collector current and emitter current will become equal. Okay sir, this is enough. Now from the data given, the value of collector current is given, thermal voltage Vt is given. By using this we can calculate the value of Re. Yes or no? Emitter dynamic resistance. Directly we can say that is Vt by collector current Ic. 26 by 0.5, it will be 52. Milli will get cancelled out. Both are milli, so milli will get cancelled. So we found the value of dynamic resistance directly. Next, come back to the question now. If you observe the circuit carefully, capacitors were given and the value of capacitor is given as infinity. So what I told you, whenever we are calculating voltage gain, current gain, input impedance, output impedance, we have to do AC analysis. So while doing AC analysis, the step number 1 is we have to deactivate all DC sources. Second thing, we have to short circuit all capacitors because we are doing low frequency analysis. At a low frequency analysis, the value of capacitors are very large. See, they also told that the value of capacitor is approaching to infinity. When capacitor is approaching to infinity, what is the value of the reactance? The value of reactance Xc is equal to 1 upon J times of omega C. When C is approaching to infinity, reactance will become 0. Reactance 0 means capacitors will get short circuited. So you can remove the capacitor by a short circuit. Similarly here also. So I am shorting the capacitors. Now see there, after shorting the capacitors, shall we start doing AC analysis now? So if you do the AC analysis, this capacitor will get short circuited. In order to deactivate the current source, I have to open circuit it. Yes or no? How will you deactivate the current source? Current source will get deactivated by open circuit. Voltage source will get deactivated by short circuit. But the problem is, this is useless now. This port is already open. So there is, what is the point of thinking about this ground? This entire branch will going to be removed from the circuit. After that, come back to the base terminal. Since this base terminal is directly connected to the ground now, when we are short circuiting this capacitor, directly this ground will be existing here. It means this 100 kilo ohm resistor also directly connected with the ground and that base also directly connected with the ground. So what we can do is, we can draw a line like this. 1 minute. So this resistor will be directly connecting with the ground, base also directly connecting with the ground. Can I do like that? Yes sir. And after that we have to, it's time to observe one more thing. What is the another thing sir? See there, if you observe exactly at this point, suppose I am calling it as collector terminal here, between collector terminal and ground we are having 1 kilo ohm resistor. This capacitor is short circuited. No need to consider that capacitor effect now, that is short circuited. In the sense we have only 1 kilo ohm resistor between capacitor and ground. Similarly, in the left hand side also, between capacitor and ground we have same 100 kilo ohm resistor. So it clearly indicated that the value of 1 kilo ohm resistor and the value of 100 kilo ohm resistor both are going to be connected in parallel. Yes sir. So always whenever you are having the doubts, it is very important to position the resistor at the correct place. Otherwise while doing the calculations, automatically it will leads to wrong answer. Okay, so don't forget to do that. So this 100 kilo ohm and this 1 kilo ohm will be connected between the same position, collector and ground. Now it's time to redraw the circuit. You know how to redraw the transistor. Transistor can be replaced by RE model or R-pi model or hybrid model. You can go with any one model according to your conveniency. So I have already did because I don't want to waste the time. Already we have been calculated all the parameters. We know how to bring the RE model. So here I brought the RE model already. See there. How will you do that? Transistor can be replaced by, from the base terminal we have to observe beta into Re, then collector terminal. See there, this is the collector terminal. Here we have to consider beta times of IB. After that, I told you that 1 kilo ohm resistor and 10 kilo ohm resistor both are going to be connected parallel to each other. That is what I did here. 100 kilo ohm, 1 kilo ohm both are connected in parallel. That too, they are connected actually across the collector terminal only. Similarly, if you observe the emitter terminal, we are having 50 ohm resistor and input voltage Vin. Now, I would like to ask you one more question. What type of configuration it is? Whether it is common emitter configuration or common collector configuration or common base configuration. Sir, since base is connected with the ground, whereas input voltage will be injected across the emitter, output voltage will be measured across the collector. This is called common base configuration. Base is connected with the ground. That's all. It is over. Okay, sir. Now, after that, if you observe, now rest of things I have written already. So, this is the collector current, the branch current, this is called emitter current. So, the voltage drop can be written as emitter current into resistor value. According to direction of the current, current entering point plus leaving point is minus for the resistor. Then what you have to do is apply one KVL for the input loop. If you apply KVL, here actually we are receiving the base current, current entering point plus leaving point is minus. So, now see there, if you apply KVL for the input loop, we are starting from minus Vn, after that minus 50 times of IE, after that minus beta times of RE into IB. This is the input expression. From this, by reducing this, we will be getting the input voltage. Similarly, take the output portion. See there, collector current is going in the upward direction. So, according to collector current, you have to mark the polarity as plus minus, but whereas the voltage polarity is opposite to the collector current. We are measuring the voltage from here to here. So, both are opposite to each other. So, I can write that the value of output voltage is IC into, see there, what is the voltage drop? Collector current IC into resistor. What is the value of resistor? Actually, this is 1K. I made a mistake everywhere. Kindly, what I can say, correct it, right? See that is 1K. Parallel with the 100K, that's all. So, 1K and parallel with the 100K, 1K parallel with the 100K, fine sir. So, into collector current, that will give you the voltage drop. After that, both are having minus. In both expressions, we got minus. Now, it's time to take the ratio between them. If you take the ratio between them, what you will be getting? So, here output voltage can be written as IC into 100K parallel with 1K. Yes, sir. Input voltage can be written as beta times of IE plus beta times of RE into IB. Whereas we know IE is equal to beta times of IB, but it can be approximately equal to beta times of 1 plus beta times of IB equal to IE. So, 1 plus beta is approximately equal to beta when beta is very large. So, directly you can substitute all the parameters. See there, now I have replaced IE by beta times of IB. Similarly, we already know the value of RE. RE value is 52, we have explored. Do you remember? Starting itself I did. The value of RE is 52. So, you can substitute the value of RE here. After that, that's all. Everything is over. Beta times of IB into RE. RE is 52. 52 times of beta into IB, here 50 times of beta into IB, overall will become 102 times of beta into IB. So, beta into IB will get cancelled finally. After that, what we have, if you approximately, just to reduce the expression, 100K parallel with 1K, how will you rewrite this? 100K parallel means into 1K, in the denominator it will become 100K plus 1K, approximately that will be equal to 100K only. Yes or no? So, we can directly reduce this. So, finally, this will get cancelled out. I am repeating one more time, 100K plus 1K, approximately that will be equal to 100K. If you are willing to write down the actual value, you can substitute, take the calci, reduce the answer. 1K equal to 1000, so 1000 by 102. So, totally the overall value will become approximately equal to 9.7. So, that is how we are calculating the voltage gain. Now, I am giving you one small homework question. Take the same question, I just wanted to know the value of output resistance and input resistance for this circuit. Can you please do me a favor? Take the same circuit, please be patient. I have already taught you how to calculate the input resistance and output resistance. So, try to rewatch the lecture one more time, understand the procedure, apply it and try to evaluate the value of output resistance and input resistance. Drop your answer in the comment section. So, whoever are continuously dropping the answers in the comment section correctly, so you will be continuously observed. After that, soon you all will be rewarded, okay, because we need interested people. I am delivering all this content for the person who is dedicatively working hard, right? So, try to utilize the lecture in a proper way. So drop your answer in the comment section. Remaining things we'll see in the next class. Thank you all.